Hi, everyone. Welcome to our C++ Integrated Development Environments workshop. My name is David Shoney.
I'm Gavin.
And today we're going to be talking about using integrated development environments to create C++ code. First, what is an IDE? IDE stands for Integrated Development Environment. It is a place where developers are able to write their code, run it, use a debugger, in addition to building automation tools and version control with Git or GitHub. There are many common IDEs for free, such as Visual Studio, PyCharm, and Eclipse, and more. Many of these IDEs are made for a specific language, such as PyCharm is made for Python or a set of languages. For this specific workshop, we'll be learning one of the most prevalent and multifunctional IDEs, Visual Studio from Microsoft, as well as a cloud-based IDE that's free called Replit. So a common confusion that many new programmers face are the difference between a text editor and an IDE. Both are used for writing and developing code, and many developers use both, but text editors only focus on the writing of code. There's no compiling or running of the code, no sort of fancy tools. But IDE usually contains all a text editor does and more, with a compiler, debugger, automation tools, and version control integration using Git. Usually a text editor needs plugins or at least a second software to fully develop code, while an IDE can handle the entire process from start to finish.
Next, I'll talk about Replit. Replit is an online IDE which allows users to write, compile, and run code directly from their web browsers. This means that multiple users can work on the same code in real time. Replit includes various tools such as AI suggestions, a debugger, and other settings that the user can set. Replit also features a cloud-based storage, which means that you can sign in on any device and access your projects. Lastly, it's very easy to set up. In order to set up Replit, all you have to do is go to repo.it and sign up for an account. If you want to create a project, go to the homepage and click on Create Repo, then choose the correct template for the language you want to explore. For us, we'll be primarily using C++. Lastly, projects are stored under My Repos. So first you'll want to head on over to repo.it. And in the top right corner, you'll click Sign Up. Since I already have an account, I'm going to log in today. This is the homepage of Replit. In order to create a project, you'll want to click Create Repo, and then choose a template for the language that you're using. In our case, we'll be using C++. Then you'll want to title your project whatever you want to name it. I'll be naming this C++_workshop. On the left-hand side, you can see your file explorer, where you can click on Files. In the middle, you can see your editor, where you'll be writing your code. And on the right is the console, where your output of your code will be after you run it. In the middle, you can see that the sample code that Replit gave us prints out Hello World. And if I click Run, you can see that it prints out Hello World in the console. If you're running into problems with your code, or you want to see your code line by line, then you'll want to debug. You can find a debugger in Replit under the Tools section, and then you can add breakpoints by right-clicking on a line, then clicking on Toggle Breakpoint. Breakpoints are important because the program will pause during execution at breakpoints and will display the values of all variables. Then you can hit play, then check the variable values, and then click on next line once you're ready to go through the next line.
Now we will show you how you can use Replit in debugging your code. Here we are given some sample code. The purpose of this code is to take an array of a certain size and to be able to output the sum of all the values in that array. Here we initialize that array to contain integers. The size is 5. Next, we change 2 values in that array. We have the value at index 1 of the array to change and the value at index 2 to change. Remember that for C++, arrays start with an index of 0. So the value at index 1 would actually be 3, not 5. And for 2, it would be this value 4 right here would change, not the value 3 to 0. Next, we're going to call up a function called sum that's defined here at the beginning. And sum will take a parameter of an array as well as the size of that array, both as integers. Then we are going to take sum to be 0 to start us off. And then we're going to run a for loop where each iteration of the for loop will add the next value of the array to be added to it. And then we finally want to return that sum. At the very end, we are going to print out the output of that. So to start off, we should see what our code is supposed to output. So if we take our starting array and then we change the two values, so the value at index 1 should be 6 instead of 3, and then the value at index 2 should be 0 instead of 4. So 5 plus 6 plus 2 plus 1 should be 14. So when we run our code, we should expect to get an output of 14. So run our code, and the sum it gives us is 32. This is not what we expected. So now we're going to have to run the debugger. So you can find the debugger under tools right here on the left. If you scroll down, it should be right here at the orange button. You can click that. And on the right, instead of the console, you'll be shown the debugger. The debugger allows us to see the values of variables throughout the code as it's running, so we can see in real time what it looks like. To start off using a debugger, we want to set breakpoints. Breakpoints can be thought of as a pause button on our code. It doesn't crash it or end it, just lets us peer into what the code is doing as it's running at a certain point. So first, we want to set a breakpoint here to be able to make sure at line 24. And you can set a breakpoint by left clicking to the left of the numbers, or I can also right click to the right. And then once the menu is popped up, I can scroll down to toggle breakpoint, click there, and also set a breakpoint as well. So I want to make sure the two values are changed correctly. I also want to click a breakpoint right here to make sure that it passes the correct parameters into the sum function. Scroll up here, when it runs the sum function, I want to stop it at the for loop as well, just to make sure that everything is running. And then finally, I'll stop it at return sum to make sure that our sum is outputting correctly as well, before it finally prints it out to the console. So now I'm going to click the blue button here under run for the debugger. If you press the green one here, it'll run without using the debugger. So you want to make sure you're running the blue button run under the debugger console page. So I'm going to press run. And there we go. Because we set a breakpoint here at line 24, then it's going to stop at line 24. Well, some people might say, why doesn't our code run through the first part? It's because our function is going to run the int main. When we call to other functions outside, it will then jump up lines to those. But for now, we're starting at line 18 when the code really executes. So at line 24, we stop, and we see that the array changes. The array of 5, it's 5. And then next step, array 2. So now if I click down, I can see all the values inside the array. So we see after we ran line 24, we see that the value at index 1 changed to 6 as we expected. And if I run to the next step or the next line, and I click back on array, we see that 0 changes to the value at index 2. So those two lines work great. Now we see that result int is a random number. This is expected as we haven't initialized result to a specific number. So it'll store whatever was in that area at memory into that value. Because we're going to be changing the value result, it doesn't matter for right now. Now I can press next step. We see sum is equal to 0. And that initializes here. Perfect. I can also run to next breakpoint, which will run which will run all the lines in between this point and the next breakpoint, so that it causes us to be here. So now we are going to enter into the for loop. We want to make sure that each iteration of the for loop is giving us the correct value. So I'm going to press next up, and we see that the sum, but we see that 5 is the size of our array, and that is correct. So when I press the next step, it says that our sum is int. However, if you remember correctly, our array, the first value should be 5, but it does 6 instead. The reason being, if you notice, our I is still 1 when we started off. However, the index here is actually 0. So we can change this by changing our code to start at 0 instead of 1. I'm going to press next step. However, the code will still run based on how we put it in originally. So this change won't be reflected unless we stop the program and run it again. However, we're going to continue run it to see what other changes we can make. So I will continue running through it. The sec I becomes 2. And then if we run it, it should be 6 plus 0, which is correct. And then we should have 6 plus 2. So after this, it should give us 8, which it does under some int. And then if I run it again, it should have 8 plus 1. So if I run it, it should be 9. Now, because our array is size 5 and we start at 0, we should be at the end of the array, and now it should quit out of the for loop. However, it continues to go through the for loop. Because we have said that I needs to be less than or equal to the size, meaning I is equal to 5, is still going to run the code because I is less than or equal to size, still falls within the parameters that it's asking. So now we're going to want to delete the equal sign because I must continue to always be less than the size for it to run. Otherwise, we'll go outside the bounds of our array. Showing when we run the next step, that sum has not changed at all because we have reached outside the boundaries of our code or of our array. Now, when I run now it should run out and it should lead us to return sum. Then when I run it to next, we see that our result is 8, which is incorrect, but now we have reasons why. So now I'm going to stop the debugger. And as we have fixed the 2 parts of our code, we can try running this again. So I'm going to take off the breakpoints at 24 and 25 because we found out that those 2 lines work correctly. As well, I'm going to take out the line here at 31 because it seemed to pass the correct parameters as well. So now if I run the code, so we see I starts at 0, which is what we were hoping for, as the index starts at 0. Our sum is 0, and our size is 5. Everything looks good. So I'm going to press next. And then after I run this, the first element should be 5 plus 0 should be 5. Correct. And if I run it again, now we have 1, which should be the value 6. So it should now be 11. Correct. And if I run it again, it should be 11 plus 2. Or 11 plus 0, sorry, which should be still 11. So if I run it, yep, that iteration gives us 11. The next iteration should give us 11 plus 2, which should be 13. And then finally, we should get 13 plus 1, which should give us 14 for the last iteration. And we see that I is equal to 4, which should be less than size. Because this is 1 was the last value in our array, then we should now exit the for loop. After this, it is exited the for loop, so that works correctly. And we see that sum is equal to 14, which is what we are looking for. Now, if I run to the next breakpoint, it'll run to the end of our code. And we saw that the sum was correct. So now, if I take off my breakpoints and I run back to the console, now If I run our code, it says that the sum of the array values was 14. Now we will talk about Visual Studio. Visual Studio is a tool which can be used through the entire process of a developer. It is another IDE that is created by Microsoft. It is used for coding websites, mobile apps, video games, desktop applications, aerospace software, and almost in every other industry with code. Users are able to write code, debug, test their code, compile, and finally finish their program, similar to other IDEs, but far more powerful in Visual Studio. It is used by over 400,000 companies as their primary IDE. Why use it? It's found in all over industry. It's a suite of tools beyond just a text editor and build scripts. It's very feature-rich with testing tools, Git integration for version control, live code sharing, AI-assistive tools, and so on. It features aid for navigation and debugging of large projects with complex data structures and several layers of APIs.
Next, I'll talk about using Visual Studio. So if you want to set up Visual Studio, you can open the Visual Studio application, and then to create a new project, you can choose empty project. And then you also want to name and choose the location of the project. Then right-click on source files, click add, and then new item to add a C++ file. Lastly, after that, you can write code in the IDE. So after you've opened the Visual Studio application, you can head on over to create a new project. I'm going to choose empty project for now. And then name your project. I'll name this C++ workshop. You can also choose a location. This location is fine for me. So then I'll create my project. And once you're in Visual Studio, this is where you'll be working. On the top, you'll see your menu bar where you can select files, edit, view, also use GitHub features, access projects, build, debug, and then test, and among other things. You can also use the search bar to search anything you want in Visual Studio. And then at the Solution Explorer are where your files are located. You'll have header files, resource files, and source files. Header files are usually where the header files are located, and then source files would be the .cpp files. Because I want to create a .cpp file, I'll go to source files, right-click, add, and then a new item. I'll name this hello world.cpp. And this will open up an editor for my file. I'll paste a hello world code here. And if you want to run this code, you can click on this triangle right here, and it'll start without debugging. You can also hit Control F5. Your output will be located on the bottom, and it'll print out a terminal which prints out hello world. To debug in Visual Studio, you want to open the debugger by clicking on the local Windows debugger button. This resides below the menu bar in the default window layout. You can run the program with the debugger on, which shows the variables and processes on the right panels. Then you can set breakpoints by left-clicking to the left of a line or right-click anywhere on the line, and then run the debugger for it to show variables of the selected line on the right panels in the default window layout. For arrays or other data structures, you want to hover over the variable to see all the elements found inside. After going through a breakpoint, you can either step into or step over preceding lines. You can use the auto window found on the right to see values of all variables in the code as you're running it. Now I'll show you how to debug in Visual Studio. So just like the Replit example, you want to set breakpoints at where you think the code got wrong. So to set breakpoints, all you have to do is go over to the left side and then a yellow circle will pop up. And all you have to do to set a breakpoint is you just left click and the circle will become red. That indicates that your breakpoint has been set. So I'm going to set breakpoints at lines 24 and 25 because I want to check if my array values are being modified correctly. I'll scroll down. I also want to check if int result is being stored correctly. And also I want to see if sum is returned correctly. So I'm going to click on line 15. And to start the debugger, you want to hit on local Windows debugger. So you can see that the debugger basically ran up to line 24, which is where our first breakpoint was. And you can see your values, your variable values under here. And you can see that int array has values of 5, 3, 4, 2, and 1. This is what we expect from the array because we initialized the array to have these exact values. And you can also see that array 1 still has a value of 3. However, as we go to the next breakpoint, you'll see that, or we should expect that array 1 should be the value of 6. So all you have to do is click on step over, and this will basically go to the next line. I click that once, and now we're at our next breakpoint, and you can see that the index 1 of array has been set to 6. You can also go to the next breakpoint by clicking continue, which I'll do so here. And you can see that the second index has been now changed to 0. So since I want to see what's going on in the sum function when we called it, you can click on step into, which will basically help you step into a function. So as you can see, I stepped into the first line of the sum function. Then I'm going to step over to go to the next lines, step over, and then I'm going to want to enter the for loop. So I'll click step into once again. So now we're in the for loop. I'll click step over. And then you can see some of new variable values that pop up. We have I is equal to 1, size value, and also the sum, which is equal to 0 right now because we didn't add anything up yet. You'll see that value, or we should expect that value to change once we hit step over again. So after clicking step over 2 times, you can see that the sum value has changed to 6, which is what we expect. So now I'll step over a couple more times. Step over and step over. And we can see that sum hasn't changed this time. It stayed at 6 because we notice if we scroll down here that the index 2 of the array is 0. So 6 plus 0 is just 6. If you want to exit a function, all you have to do is instead of step into, you would just step out. So since I'm done with this and I want to check to see what return sum is, I'm going to click step out. And we can see our sum is not being added correctly, and it has a very random value. I'll step out again, and then we'll go back to int main. And you can see, yes, since sum has been returned and result is equal to sum, then the result value is also being messed up. So I'll step over until our code ends, and then the debugger has been closed. So I'm going to go over here and modify our code to be correct. Like I said, int I should be equal to 0, and I is less than size. So now that our code is correct, we can run it once again. Hit start without debugging. And in our terminal, you can see sum of array values is equal to 14.
And we will end our workshop today with a famous quote by Wolfgang Amadeus Mozart. In the symphony of code, debugging is the virtuoso performance that turns dissonance into harmony, transforming bugs into the silent applause of a flawless composition. Thank you everyone for listening.